Hello, everyone, and thank you for joining us today for this webinar, Get the Most Out of Neural Machine Translation with Rich Training Data. So today, our speaker, Paul Kayuka from SYSTRAN and Umit Ozaidin at Dragoman will take you through this interesting journey that they had in developing the Turkish English machine translation engines. Just a few attendance questions. This webinar is being recorded, so your line is on mute, but please, if you have any question, don't hesitate to leave them in the chat panel above your screen, and we will have a Q&A session at the end to answer all your questions. So now I'm leaving the floor to Paul, and please welcome SYSTRAN.
Thank you, Alice. And welcome everybody. This is Paul speaking from SYSTRAN. So we are very happy to co-organize this webinar with our partner Dragoman. And actually with Umit, we were quite excited to walk you through our experience in developing a translation engine that combines actually Dragoman rich data with SYSTRAN technology. So in our agenda today, we will start by talking about the growing need for customization in neural machine translation. Then the importance of data that we fed to engine to customize it or improve it. At the part 3, we'll be talking about the Dragoman SYSTRAN engine, co-developed engine, to show you some results that we get that are quite promising, and also a live demonstration just to showcase really the robust and the adapted engine. And at the end, I will be talking about the benefits for end users, how they can interact with these engines to go further than just the initial training and access these engines with many translation features. So to start with, you can see on the screen, this is Gartner's hype cycle. Actually, this is a very simple visualization of an emerging technology, so showing the different phases of an emerging technology. So it's really interesting to see this with neural machine translation, which was launched at the end of 2016. It went through different phases until today, 2020, and it almost immediately went crazy with an enormous peak of inflated expectations. So this technology was on newspapers, talked everywhere, and we go even so far to question if the translators were needed anymore in the future. So following this high expectations, of course, we had a phase of disappointment. So where, which we call the disillusion, that came from the absence of further technological improvements, starting from 2017. So at the end, this expectation and reality has balanced at the end with the plateau of productivity, which was driven by two main things, which are the integration to the production flow of neural machine translation and the customization. So we will be looking deeper into customization during this webinar. So we can very simply make an assumption that if with neural machine translation, we are getting a higher quality, so do we need less customization because the quality is quite sufficient? So we can answer this question by taking a look to our activity at SYSTRAN, because actually we are known as a custom MT provider. We are doing MT for 50 years now. So if we take a look on a very interesting graph that I would like to show you, is this graph, so which is representing actually horizontally the translation quality, so the basic out-of-box quality, starting from 1980. So you can see the 3 technologies presented, the rule-based, statistical, and neural machine translation. And also vertically, you see the share of our activity spent on customization versus on the technology itself. So at the rule-based period, the base quality was too low that even to be able to use the machine translation, we need a lot of customization. So that's why there was an increase on the customization to get this machine translation usable. Then with statistical machine translation, the game changed, and the jump in quality was very important, but it was mainly based on the technological improvement. So the customization was not a priority, it was at the second plan. Then the surprise that we saw with the NMT, because of course there was a huge jump of quality that was very promising in terms of out-of-box quality, but we have also quickly seen that it also came with a huge demand of customization. So the question to ask here is why? So why this customization demand was growing so much, while the quality has never been so high? So there's different reasons of that. The first one is that the core technology itself is not a differentiator anymore, because actually the NMT state of art is gone open source, and we did the same at SYSTRAN from the very beginning by building an open source community called OpenNMT. So this is not anymore a differentiator between different machine translation providers. The second thing is that the customization with NMT is not anymore just a bonus. So it's a must-have for production flows. And the main reason for that is that when we customize an engine, we saw that there is a 15-20 blue points over a generic translation, which is huge. Because just to give you a comparison with statistical machine translation, we were talking about 2-3 blue points over the generic translation. To simplify, Google was communicating that to gain 1 blue point, we need to double the translation data, the training data. So you can imagine that 15-20 points is huge, and it makes a very big difference. And this also combined with many emerging customization techniques that could be static, like the training phase and so on, but also dynamic, which also includes the translator themselves to interact with the engine and customize further. And the last point about this growing need is that since 2016, we saw that the NMT now is being commodity, so it's available. It's not that expensive anymore, but now with the converging offer and demand, custom NMT is becoming the standard and not anymore the generic NMT. So the first task in terms of customization is the domain adaptation. So when I say domain, it could have a very broad definition. So this could be a very general topic like finance, IT, gaming, legal. It could be company specific. It could be use case specific. For example, chat is a different domain. Formal, informal is domain. Even a style of a translator could be a different domain. So you can imagine that when we have one domain, it's easy to train it with the generic plus domain data and start to translate. But things start to be tricky when we have more than one domain. So for example, with the engine that we have developed with our partner Dragoman, we had 6 different domains. So it becomes too costly in terms of time and energy to maintain 6 different training versions of these engines and update them continuously. So one alternative approach of that, instead of getting different versions, is to overtrain one generic engine with new coming domain data. But that's also very risky because it comes with a catastrophic forgetting for the engine, because actually when you start training your model, the model will start losing their knowledge from the initial training. So it's not very efficient. So that's why the approach that we have followed with this training was to get all this data together, all domain data, generic data, train one big model, which would be a multi-domain model, but also adding some features such as domain selection to let the end users dynamically select which domain to translate with and get the best results. So optimizing this customization flow requires many things. So one of them is the main input for this customization flow, the data. So of course, optimizing this flow is one thing, but the output quality of an engine will heavily depend, like the accuracy, the fluency on the data. So not all data are equal for the same customization or adaptation task. So what we are looking for here each time when we develop a new engine is a rich data. So we are looking to really to develop a robust and high quality engine with a rich data. So what makes a data rich? The first thing, this data should be adapted to the domain. So it should be corresponding and representative of your daily translation task. Of course, we cannot expect the data to be 100% perfect, but even if we have some errors or noise in the data, it should be also relevant to your task, like the daily errors that you can make as a translator or content generator. The second thing, of course, which makes a big difference is that we are looking for a high quality data. So that means that it's consistent in style and following some defined guidelines, but also looking for a large coverage of domain expertise, because with that, we can avoid any unseen terminology, which can finish with a surprise translations at the end. So for that, a large coverage of the domain expertise is quite important. And finally, having adapted and high quality data will give us good results, but also we are highlighting the importance of responsible data. So today, with the huge amount of confidential data, like personal information, medical information, is uploaded to online platforms, which has normally unacceptable terms and conditions. So that's why we highlight the importance of the responsible data, that the data is traceable, and we indicate in a transparent way the ownership of this data. So now I will hand over to Umit, who will be talking us about how Dragoman built this rich data.
Thank you very much, Paul. Hi, everyone. Well, Dragoman has been in the international localization market for over 15 years, and we have over 500 active clients. And in the past 15 years, we have undertaken over 50,000 projects in 80 languages. Now, creating data out of 50,000 projects for hundreds of clients is never an easy task, but we think we found an easy way to do it. I will continue in the next slide. One of the things we are doing is we continuously tag each project we create on our system. I'm going to show a screenshot in a minute. And we do this in a multi-domain way. It's very simple, and every project manager with just a few hours training can learn it. And we are very committed to do that. And to assure quality of our data, we always have native speakers reviewing our translations, and then we do terminology management. And we are always consistent with the client terminology or history. And then every now and then, ideally 6 months, sometimes 12 months, we clean our translation memories, which is very, very important. Remove the conflicts, and then we give feedback to our team about any inconsistencies, be it stylistic or domain related, and we feed this back to our team. Can we move on to the next slide, please? Well, I think this is crucial, and a lot of localization managers and also MT providers have this misconception. They think there is medical English or there is automotive English. That's the biggest mistake. There is jargon. You may have a terminology for medicine or cars or finance, but language is a whole, and thinking in compartments will only deliver poor results. Next slide, please. So to avoid this compartmental thinking, we have a multi-domain tagging. For example, this is a screenshot from our TMS, which is Nubuto, a version of XDM Cloud, an excellent system. What we do is, while we are creating a new project, we have very easy to remember tags like finance, but then it can be accounting, but maybe an accounting company is marketing their products. So we are combining a marketing tag with an accounting tag. So this prevents compartmental thinking. And hopefully when we feed this to a great partner like SYSTRAN, as Paul mentioned, they take all these tags and then start building an engine. And I think here I hand it over back to Paul.
Yeah, thanks, Umit. So yeah, as Umit mentioned, actually having this rich data with tags and more contextual information, and having also the optimized customization flow defined, actually at SYSTRAN, we are enabling the technology and computing power behind for partners like experts like Dragoman, who uses their rich data and provide the best of breed neural machine translation engines to end users. So this is done, the training process is done on SYSTRAN Model Studio, which goes through different steps, starting from data preparation by taking in account all this input provided with the rich data, model training, also the evaluation of model in real time in an automated way, but also some manual steps to fine tune again the training, and at the end publish this model for the end users, and they start to translate with. So we went through this process with Dragoman, which was a great experience, and we have developed an English-Turkish multi-domain engine that are newly published on SYSTRAN Solutions. So now I would like to have a look on the results from manual and automated evaluations that we have did, but also to show you some real live samples with these engines.
Yeah, maybe I can talk about this slide, Paul. We had a panel of 100 linguists. 50 of them were internal and 50 of them were external. We published a survey on social media and asked people without any branding. We didn't name SYSTRAN or others. And we said, which of these empty engines or empty outputs would you prefer to use or do you like the most? And as you see, SYSTRAN consistently was chosen the best option as compared to other industry alternatives. I mean, I'm not going to name each one of them, but I mean, I can only say we compared SYSTRAN against Google, Bing, and Yandex. I'm not going to say which one is which, but in all cases, SYSTRAN was consistently was marked better than the others. But then this is 40% because in some cases, let's be honest and direct, the linguist did not like the translation output, meaning we did not only filter the best outputs we give, because otherwise it would be 100%. So we just had a random selection of sentences and then shared it with the public. And this was the result. 40%, I think, is a very good human review. I think the next slide, Paul, you can explain better about the automated one.
Yes, of course, the blind test is very valuable. Beside that, to go more like deeper to the test and compare engines with automated scores on each domain. So at the bottom, you can see the 6 different domains that this data was representing, and we have calculated the blue score, comparing 2 empty engines, which is Google and Microsoft translation engines, with Dragoman SYSTRAN engine. So as you can see on the screen, the difference on the blue score represent well the assumptions that I was talking about, the growth of customization, which is around 10, 15 blue scores on each domain. So now I invite you to take a look with Umit in a more concrete way with real samples translated with this engine.
Well, thank you. If I can share my screen, I will be happy to demonstrate. Thank you. Well, this is a public website, translate.systran.net, and our engine is published there. You just go there and select Turkish to English. Well, I mean, I have prepared a couple of sample sentences. I'm going to show them to you, but then I'm also going to show the multi-domain behavior of the engine. For example, a very rare word like fractionator. This is a word in energy industry, and it means fractionator, which is very rare. I mean, given the rich data, you know, millions of segments and hundreds of thousands of terminology provided to SYSTRAN by Dragoman, our engine, you know, is so good in finding the right terminology in multiple domains. Or, for example, it could be motor, kasko sigortası, which is in English, motor, yes, I'm sorry, kasko, not kaskor. Yeah, motor vehicle insurance. So in terms of, I mean, terminology base, this is a very rich engine, but I can take you to other flavors. For example, let's go to history and say, well, the Turkish sentence, not everybody is bilingual, but you can check from the right side on the English. Let's say the American Army entered Vietnam, okay? And continue and check out how the model changes. Okay, so, and then maybe we could say even longer sentences. Hold on, yeah. So when the American Army entered Vietnam, it faced resistance from the Chinese-backed Viet Cong. Okay, for example, we can say a fierce or harsh resistance recognizes, okay, and then maybe we could write a better one or a longer one. So, and still recognizes it, and then, or we could say, so I mean, the more the sentence, I mean, goes and on and on, and I mean, I tried this with even longer phrases. The SYSTRAN Dragoman model sustains a meaningful sentence much longer than the other commercial alternatives. I mean, you can go and check with many different sentences on this website, but I prepared another example for you. Here you see the multi-domain effect. The word görüşme in English means interview or meeting. And these are a couple of sentences, and see how our model reflects the context. For example, there is a meeting with the director and it recognizes it's a meeting. But then if they are talking or discussing about sales performance, the model immediately recognizes it's a sales performance and it's a discussion and says discuss. And then if it's about performance discussion, a more formal way of translating that would be performance review, so, or interview. So the model says performance interview. And or if you are talking to your girl on the phone, your daughter, that will say a phone call. The same word, this görüşme, the same word with different Turkish suffixes. And then maybe it's a face-to-face meeting, and then again says, well, this is another discussion as well. What I'm trying to point out here is when NMT is fed with rich data, with millions of segments and hundreds of thousands of terminology, and trained well, it can change the translations on a sentence level as well. So I think, I mean, this proves the case. I'm not saying, I mean, our model, and I mean, I noted this. I mean, I don't want to create a hype. I'm not saying we don't need any more translators, because there are so many other examples that the model would fail. But as Paul said, and as our blind test confirmed, at the moment, our model performs much better than the commercially available alternatives. And with that, I hand it over to you, Paul.
Thank you. So thank you, Amit, for this demonstration. So at the last part, I would like to mention how the end users can benefit from this technology and other translation features. So one important thing, we would like, with today's technology, we would like to go beyond the initial training phase, because that's a real static adaptation. So taking the data, training the engine. Okay, we have this multi-domain engine. Then how we can dynamically go further and adapt more this engine. So our solution comes with different features for dynamic adaptation. This gives the possibility actually to end users or post editors, translators, to interact with the neural engine and have this continuous improvement flow. So this could be done at different levels. During the translation, you can dynamically inject some custom dictionaries, so which includes your own terminology, wording, abbreviations, product names, and so on. So this could be injected in real time during the translation. But also when we go through a post-edit flow, we have this very valuable output, which is the post-edited translation memories that can be used in two different ways. So the first one is the neural fuzzy technology, which is a fresh development at SYSTRAN, which actually lets the engine, while translating, to go and search for some fuzzy matches and adapt the output to these fuzzy matches. So it means that in real time, dynamically, the output is adapted to the translator or post-editor style. And once this translation memory is collected as well, it could be used to overtrain incrementally this engine, which is already adapted to different domains, but you can continue to adapt it to your own organization or your own business case. And all of this today, with more than 5,000 trained model, dynamic adaptation features, translation features, are proposed thanks to SYSTRAN Technology plus our expert partners such as Dragoman. As end users, so you having different activities in different industries, you can access and start to use it with SYSTRAN Solution Suite. This solution catalog covers all different needs from, as Amit showed as well, from an open platform that you can test just after the webinar. I invite you to go and test our available engines, which is SYSTRAN Translate. Also a SYSTRAN API, which is a cloud offering for developers. SYSTRAN Pro, a cloud offering for professionals, actually, which comes with user-friendly features such as translating Microsoft Office files, PDF, image, websites, and also injection of your translation memory terminology using it with CAD Tools and TMS. And finally, for companies, we have our enterprise server solution, which is deployable on private cloud or on premises with all of these features. So I invite you to go to this open platform, translate.systran.net, to test all these engines, including Dragoman, SYSTRAN, English, Turkish multi-domain engine, and contact us to discuss your translation project or to explore the possibility of developing such engines with your own data. Thank you for your time.
Okay, thanks everyone. I've already seen a couple of questions in the panel, so don't hesitate if you have another question to ask them on the chat panel. I have one actually is on the quality evaluation. You've addressed this during the webinar, but maybe it would be nice to give a small recap on how do you evaluate the quality of the engines?
On my end, we are using a template provided by SYSTRAN. Initially, that's what we do. It has scoring like 0, 1, 2. Like if an output is totally irrelevant or ununderstandable, you know, it is 0, and if it is little bit understandable, 1. If it is clear and I mean, there's this marking. So that's the first thing we do. But while we are doing this, we are using sentences which were not used to train the engine. Because if we use the same sentences, there's no point. The engine will respond positively anyway. So we randomly select sentences from websites or from other translation projects which were not involved in building this engine. That's the first step we do. That's an internal step. On the second step, we choose other sentences, and then, you know, I mean, and sometimes paragraphs too, and send it to our internal linguists and ask them to, you know, score it. On a third level, which I didn't mention, I forgot to mention, we enabled SYSTRAN Translate on our TMS, I mean XTM TMS, and ask the translators just to have a look while they are translating, you know, and we pay them some extra, you know, on the top of their per word rate, just to give us a feedback. Did you like it? Were you able to use it? And of course, our TMS gives us a report on the utilization of the engine. And the utilization rate was very, very high internally. But on the top of it, we said, okay, maybe internally, you know, I am the boss, I am Ümit, everybody says nice things to me. So with the kind guidance of Alice, I wanted to make it public. So I published this blind survey on the internet, and the results were still overwhelmingly positive, which was very encouraging. So these are more or less the steps we are taking. I hope this satisfies the question.
We have actually lots of questions. So another one is, what is the minimum data required to train SYSTRAN neural machine translation? And they were asking what are the domains that are already covered in our knowledge base.
Yeah, so
I can, yours, I guess. Yeah.
I can take that question. So, so with the neural machine translation technology, the volume of the data, of the training data, is not anymore priority 1. That's why we highlighted in this webinar the importance of rich data. But of course, we still have, depending on our best practices and the hundreds of engines that we have specialized, that we recommend having at least 100K segments, aligned bilingual segments, to see a big difference with this training process. So that's our recommendation. It could be done with less data, but this is where we start to see 10, 15 points of blue score difference. And regarding the domains, the questions about which domains are covered. So for this specific code development, we were covering 6 different domains. Maybe I can just bring them back to the screen. Then, as we are addressing all different, many different industries, on our side, we have much more domains. So this could be, as I said, not just a general topic such as medical, construction, energy, but some of our customers, they would need an informal translation engine. So that would be a domain. They would need a chat engine. That would be a domain. So it really depends on what we are looking for as a requirement.
Taking another question, maybe for Umit, is that the main problem about Turkish English machine translation is the absence of sophisticated corpus of the Turkish language. So how are you planning to handle this issue?
Well, we may be possessing the largest and highest quality corpus for Turkish to English on this planet. I mean, I was committed to quality the moment I started translation industry in 1996, and I was the first person to publish an online glossary under the name Dragomanus. So terminology, quality, bilingual data, copy editing, proofreading has always been in my personal agenda and also later on my company's agenda. And luckily, Dragoman has become a very successful international localization company with hundreds of clients. And we always kept our data clean. We do our best, and I am proud of my team for their commitment to this end. I'm very happy to work with some of the best linguists available. So I think that is part of the question. The other thing is, as Paul mentioned, what the current NMT technology, which is open source, it's not the volume, it's the richness. And to make it rich, I mean, maybe we can have another session and I can show you how our proofreaders are keen to use different synonyms of the same word, like the simple word increase. Sometimes we translate it as advance or enhance or elevate. So I think the biggest problem in our industry is everything is Googleified. Everything is so simplified. And then the language loses its taste and gusto. The difference we hope to bring to this market is the skills, or the blend of skills that we have given to Paul and his team to produce some of the best engines. I think that's our difference. But I may add a remark. If you're asking, am I going to make my corpus public? No, but my engine is public. Engine is public.
Some other questions also on the what happens with post-editing and user feedbacks in regard to the model training. So how is it incorporating? Is it happening afterwards? What is the process?
Well, we can take this together, Paul. I mean, I was planning to give, feedback to SYSTRAN maybe every 6 months, because, it may not make sense to, just be a nuisance and just, give you feedback every 2 weeks. So maybe every 6 months we feed you feedback. What do you think?
Yeah, so actually, there's two different levels of that. So the first initial training that we showed, like taking the data, training the engine, that is done usually with some periods. As Umit mentioned, it could be 6 months, once in a year, depending on the post-editing volumes that you have. Then we should highlight that post-edited content is very valuable, because actually it's a post-edition of a raw empty data. So it's much more easy to feed the engine with this data, and you will see the difference better than the very first initial training. Then for the users in the production flow, they can also dynamically use this post-edited content, as we showed. So this could be an interaction with terminology injection, or the neural fuzzy that I have showed, which dynamically adapts the translation output, taking as a reference the post-edited content. So it could be used both as a dynamic adaptation in a dynamic adaptation cycle and the initial training.
There are quite a lot of questions on the language availability of the models. So I've seen if Arabic is a language that we have, and I think we do. Paul, I will let you confirm, and also Hebrew. And another question also, is it a hassle to create a non-existing language pair?
So regarding the language coverage, yes, Arabic, first of all, Arabic and Hebrew are the languages that we cover. We have around 55 different languages, mainly combined with English, but also different combinations between them. So it's quite a large coverage of languages that we can apply all these features and trainings that we demonstrate to you. The second question about creating new languages, this is something that we do also very actively. So last year, I guess we have maybe built 3-4 new languages. This year we are working now on 3-4 new languages that we didn't have in our catalog. So the technology is there, the backbone is there. The only thing that we need as an input to develop a new engine, a new language pair, is the data. So if we have the data, the process is the same, and we can just go through this process to get new language pairs.
We will take a couple of last questions. Thank you for the audience, because you are asking a lot and it's getting very interesting. I would say, what technique did you use to train the engine? Was it data annotation or some other method that you used?
So that's quite technical question. I think we can take this question after the webinar to have a more detailed response, because actually I am not involved that much on the linguistic side of the things. But from a more high-level perspective, what we do regarding all the contextual information coming from the tags, from this rich data part, we are able to flag this segments, sentences, for example. So this is a financial domain sentence. This is an informal sentence. This is more a chat adapted sentence. So all of this information are flagged during the data preparation phase before sending the model to training. So that's a work which is done just before the model training.
And maybe one last one for those whose question haven't been answered. We will come back to you by email after the webinar. Now, don't worry. How are you teaching the engine to deal with broken syntax or unusual punctuation, irregular phrases? Because it seems to be an issue that is coming quite often, especially in legal translation, for example.
Yes. So that comes to the part of where we explain the rich data. If you remember, on the adapted data part, we talk about the noise in the data. So this could be errors, that could be unstructured data, like typos or anything. So this kind of noise is already in the data. So the engine, what we try to do is to keep the source with some noise, so some errors, some typos, and so on. However, the target corpus, which is the result of the translation, we try to keep it as clean as possible. So this allows the NMT engines, and you can see that easily with different generic or trained engines, that the engines are able to correct some typos, even grammatical errors, sometimes simplify the sentence, which is sometimes could be a good thing, sometimes could be not that asked for. But yes, so the source have some noise, the source data, and the target data is clean. So that's how the engine learns also to deal with this kind of unstructured or error containing data.
And I think I saw a very last question that is interesting also for the people who are using CAD tools. Is there any automation with XTM or other CAD tools that would be helpful for the training of the engines?
So we have native connectors with all main CAD tools, translation management systems, such as XTM, which allows us to use it in a seamless way. We are also looking into having some advanced connectors which will be able to synchronize actually the linguistic resources between SYSTRAN machine translation system and the TMS system. It could be on a translation memory level or dictionary level. So these things are under development to have a more enhanced connector, because they are quite complementary tools and most of our customers are using both machine translations and TMS as well. So you can also find from SYSTRAN website, we have an integration page where you can find or ask us just about different connectors that we have and what features they contain.
Okay, thank you both. We are running out of time. So for the question that haven't been answered, we will come back to you via email. Don't hesitate to go on SYSTRAN Translate. You have their address here, and you will see all the language pairs that are already available there. And please don't hesitate to contact Paul or Umit for any follow-up or any questions that you have. Thank you very much. Have a nice day.
Thank you all.
Thank you. Thank you. Bye.
Bye.